Hi guys, we're looking at the ninth video on the topic of diffraction. There are two main types of diffraction that we need to concern ourselves with. One is through a wall, as you can see in both of these cases here. And in this first example here, in example A, um, where the hole is approximately equal to the where they're approximately equal in value to the wavelength, then we have a high amounts of diffraction. Okay, or maybe you can call it good diffraction, but it's really maximizing diffraction. And remember that diffraction is a bending of a wave or a wave front. Okay, next up, we have a much wider one. So this distance is much, much wider than our regular wavelengths. So the distance here is a lot larger, or it's very different, is what we're really looking for. Okay, whereas these over here, the wavelength is approximately or very close to D. Then we have high diffraction. So when they're radically different, then we have little or no diffraction. Okay, and actually when the slit itself is a lot smaller, so here the size of D is actually smaller than the wavelength, then it actually works as if no diffraction actually happens at all. So there's actually no effect. Oops. No effect. Okay. So even if a person was standing at point A, they would still hear music because the wavelengths are much, much larger. Okay, so here in our example here, we have somebody playing a violin. So violin has a fairly high-pitched sound, and a double bass has a fairly low-pitched sound. And so a double bass would essentially allow sound waves to travel around corners. So person C would be able to hear a double bass, whereas person C cannot hear the violin, whereas person B, well, because obviously they are in line of sight, will hear both the violin as well as the double bass. Okay, quick little revision question here. So it says there's two people here. There's a guy, person B here is rocking out with his bass guitar, and person A is just somebody standing around a corner. Keep in mind that this is an overhead view, so they can't physically see each other. But person A actually hears music played by person B. So why is that? And the reasoning is very similar to what we're seeing here, is that a bass guitar has very long wavelengths. Okay, and so the music itself can diffract even if it cannot reflect off of a surface to person A. Okay, so even if there's no wall, person A can still hear the music, and this is due to diffraction. So our second part says, what if the person played the flute instead? So rather than rocking out on a bass guitar, he's rocking out with a flute. And flutes essentially will have shorter wavelengths, and therefore it won't be able to diffract around that corner, and therefore the person would not hear a flute. Okay, right, hope that makes sense. Thanks for watching, guys. See you in